Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11 chapter 7 permutations and combinations. In the last video we were discussing how to find out the number of arrangements using different theorems. If repetition is allowed, if repetition is not allowed, then if different objects occur in P1 P different ways, P2 different ways, like that way, then the number of arrangement. These all we discussed, and related to those theorems we did a few problems, and the remaining we will discuss it now. First one, find R if 5 into 4pr is equal to 6 into 5pr minus 1. So we have to find out what is R. So we can write this as 5 into 4pr can be written as 4 factorial divided by 4 minus r factorial is equal to 6 into 5 factorial divided by 5 minus r minus 1 factorial, and that is equal to 5 into 4 factorial is 5 factorial divided by 4 minus r factorial is equal to 6 into 5 factorial divided by 5 minus r plus 1, that is 6 minus r factorial. Now in the numerator 5 factorial is common, that can be cancelled, and also we can write this as 1 by 4 minus r factorial is equal to 6 by, how can we write 6 minus r factorial? 6 minus r factorial is 6 minus r into 5 minus r into 4 minus r factorial, and both sides we can see in the denominator 4 minus r factorial is common. So now cross multiplying, 6 minus r into 5 minus r is equal to 6. Now expanding, this can be written as 6 into 5 is 30, then minus 6r minus 5r, that is minus 11r plus r square is equal to 6, or we can write this as r square minus 11r. This 6 can be taken to this side, so 30 minus 6, that is plus 24 equal to 0. And therefore what is the value of r? Here we can factorize. 24 can be written as minus 8 into minus 3, and sum of minus 8 and minus 3 is minus 11. So this can be written as r minus 8 into r minus 3 is equal to 0, or r is equal to 8 comma 3. Okay, next one, find the number of different 8 letter arrangements that can be made from the letters of the word daughter so that, first sub question, all vowels occur together. So all vowels occur together, we can write the vowels together, that is A, U, E, then remaining D, G, H, T, R. We need to find how many, find number of different 8 letter arrangements. If all the vowels are occurring together, if all the vowels do not occur together. So first case, all the vowels occur together. So all the vowels occur together, how many arrangements are possible? We can take this as a single unit. All the vowels together, we can take it as a single unit. That is, so 1, 2, 3, 4, 5, and this is a single, that is 6. So how can we arrange all these 6 letters? 6 letters can be arranged in 6 different ways. So number of arrangements is equal to, so first we are taking 1, 2, 3, 4, 5, and this as a single unit, that is 6. So it can be arranged in 6 different ways, and inside this that is A, U, E, among those vowels itself there is an arrangement. So that is U can be in the first, A can be at last, E can be in the middle. So like that way many arrangements are there between these vowels. So A, U, E, that vowels itself can be arranged in different ways. How many different ways these vowels can be arranged? Vowels can be arranged in, three vowels are there. So 3 different ways. So by fundamental principle of counting, number of arrangements is equal to 6p6 into 3p3. Hope you understood how 6p6 is coming. We are taking this, all the 5 letters here, and this we are considering it as a single unit, and so that 6p6 different ways. Whereas in between these vowels itself there will be an arrangement, and it can be arranged in 3p3 different ways. So using the fundamental principle of counting, 6p6 into 3p3, and how much is 6p6? That is 6 factorial divided by 6 minus 6 factorial, that is 0 factorial, into 3 factorial by 3 minus 3 is 0 factorial. And what is the 0 factorial? 0 factorial is equal to 1. So understand that 0 factorial is equal to 1, it is a definition. So this can be written as 6 factorial into 3 factorial, and that is equal to 4320. Now all vowels do not occur together. How can we find out the cases where all the vowels are not occurring together? So from the total arrangement, from this daughter, the total arrangement, how can you find out the total arrangement? Total arrangement is equal to here we can see all the objects given, all the letters are all different. So according to our theorem, if repetition is not allowed, then the number of different ways of arrangement is, how many letters are here? 1, 2, 3, 4, 5, 6, 7, 8 letters are there. So total arrangement is 8p8 or 8 factorial. And we need the case where vowels, all vowels do not occur together. We have already found which are the cases where vowels occur together, and also we know the total arrangement. So what about the vowels? All vowels do not occur together. Number of arrangements where vowels do not occur together. Just we have to subtract the case where that from the total arrangement we have to subtract where the vowels occur together. So remaining all cases vowels do not occur together. So number of arrangement when all vowels do not occur together is equal to, total arrangement is 8 factorial minus when the vowels occur together, that is 6 factorial into 3 factorial. So from the total arrangement, the number of cases where the vowels are occurring together, if you are subtracting, we will get the remaining arrangement. So in the remaining arrangement, vowels do not occur together. So this can be written as 8 factorial is 8 into 7 into 6 factorial minus 6 factorial into 3 factorial, and common term we can take it out. 6 factorial is common, remaining 56 minus 6, and that is equal to 720 into 50, which is equal to 36,000 different arrangements are there when vowels do not occur together. Then next one, in how many ways can 4 red, 3 yellow and 2 green disc be arranged in a row if the disc of the same color are indistinguishable? So here the objects itself are repeating. If objects itself are repeating, how many different arrangements are there? If objects are repeating, objects itself are repeating, then number of arrangements is equal to n factorial by p1 factorial into p2 factorial into etc. pk factorial. So here total number how many how many colors of disk it is given? 4, 3 and 2. So 7 plus 2, 9. So 9 factorial divided by how many each one is repeating? Red repeats 4 times, yellow repeats 3 times and green repeats 2 times. So required number of arrangements. Required number of arrangements. And that is equal to 9 factorial by 4 factorial into 3 factorial into 2 factorial is equal to 1260. Now next one, find the number of arrangements of the letters of the word independence. In how many of these arrangements do the words start with P? So first question is, we have to find out the number of arrangement if the letter, if the word starts with P itself. How many different arrangements are possible? So first we have to keep that P. Then the remaining which all it is there? I, N, D, E, E, N, D, N, D, E, N, C, E. So only thing is that in whichever arrangement, this can be arranged in any different ways. Only P you have to keep it in the first. So how many arrangements are there? Required number of arrangements is equal to, so how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters. So 11 factorial divided by how many times each one repeats? N repeats 1, 2, 3 times, 3 factorial. Then D repeats 2 times. Then E repeats 4 times. So only thing is that we have to keep P in the front and first letter should be P. Then remaining can be arranged in this many ways, and simplifying we will get this as 1,38,600 different arrangements are possible. And here it is asked, find the number of arrangements of the letters of the word independence. How can you find out the number of arrangements of the letters of the word independence? Total arrangement, that is n factorial divided by P1 factorial, P2 factorial, P3 factorial, etc. So we can see here there are 12 letters. So number of arrangement is equal to 12 factorial by each one repeats, that is N repeats 3 times, D repeats 2 times, E repeats 4 times. So only difference come is 12 factorial by 3 factorial into 2 factorial into 4 factorial. So that's a total arrangement. So that also you have to write here, total arrangement is equal to 12 factorial by 3 factorial into 2 factorial into 4 factorial. Simplifying this, we will get 1663200. Now there the second question. Second one is, do all the vowels occur together? How many different arrangements are there if vowels occur together? So as earlier we have to do. So how many vowels are here? Vowels E, 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 E and one I. So all the vowels should occur together, that is I, E, 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 E. And remaining letters that is N, D, N, D, N, C and P. So these are the remaining letters. So how many different arrangements are possible? So as earlier we have to consider this as a single unit. So 1, 2, 3, 4, 5, 6, 7 and plus 1, 8. So number of arrangements is equal to 8 factorial divided by, now each one occurs here 2 times, N 3 times, D 2 times. So 3 factorial into 2 factorial then again inside this, among this vowels also there will be an arrangement, that is total 4 plus 1, 5 letters are there. So into 5 factorial divided by E repeats 4 times, so 4 factorial. So simplifying this, we will get it as 16,800. Now the third question is, third one is, do the vowels never occur together? Which all cases vowels never occur together? So from the total arrangements we have to subtract when the vowels occur together. So required arrangement is equal to, from the total arrangement. What is the total arrangement? Total arrangement we have already found it here, 1663200 minus when vowels occur together is 16,800. Subtracting this we will get 1646400. And the fourth question, number of arrangements when word begin with I and end in P. So first and last is fixed, there is no change in that. So out of the 12, two places are already fixed, I and P. Only the remaining there will be change. So required arrangement is equal to, so remaining out of 12, 2 are fixed, to remaining 10. 10 factorial divided by each one remaining repeats 3 factorial, 2 factorial and 4 factorial. That is equal to, that is 3 times n repeats, then 2 times d, and E repeats 4 times. So this is equal to 12,600. Now moving on to the exercise questions, exercise 7.3. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? So we have to make 3-digit numbers and 9 digits are available. 9 objects are available and 3 objects are 3-digit numbers are to be made, and repetition is not allowed. So given digits from 1 to 9 and repetition is not allowed. Therefore 9 different digits taken 3 at a time, is equal to 9p3, which is equal to 9 factorial divided by 9 minus 3, that is 6 factorial, and that is 9 into 8 into 7, which is equal to 504. Then next one, how many 4-digit numbers are there with no digit repeated? So we have to find 4-digit numbers. 1, 2, 3, 4, and we are having the digits from 0 to 9. To make any 4-digit number or any number, we are having the numbers from 0 to 9. That is, there are 10 numbers and we are supposed to find a 4-digit number. But in the first place, in the thousands place, this is the thousands place, 0 cannot be, we cannot place a 0 here, because if it is a 0 here, what happens to the 4-digit number? It will become a 3-digit number. So here it cannot be 0. So out of the 10, only 9 can be filled in this. So only 9 can be filled in this first space, because 0 cannot be filled. So 9 different arrangements are there for the first place, and remaining 3 places are there to fill. And how many digits are there remaining? Total 10 digits are there. Out of that, 1 is being assigned here and remaining 9 are there, and we can arrange this in 9p3 different ways. Therefore, required arrangement is equal to 9 into 9p3, because the first one can be arranged only in 9 ways, followed with the remaining 3 digits can be 3 spaces can be filled in 9p3 ways, and that is equal to 9 into 504, which is equal to 4536. That much different ways. Now next one, how many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? So we have to make even numbers. So 3-digit even numbers means the last position can be filled only with even numbers. That is 1, 2, 3 even numbers are there. So out of that 3, we can allot any one here. So we can arrange this last place in 3 different ways. That is 3 objects are there and 1 place is there to fill. So it can be done in 3p1 different ways. That is 3 itself. So 3 different ways for the last one. Now out of this 6, 1 is already allotted here. Remaining 5. Since repetition is not allowed, remaining 5. So from the 5 we can select only 2, and it can be selected in 5p2 different ways. So number of arrangements is equal to 5p2 into 3p1, and 5p2 is 5 factorial by 5 minus 2 is 3 factorial into 3, and that is 5 factorial by 3 factorial into 3 is 60. So 60 different ways. Next one, find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated. How many of these will be even? So we need to find how many even numbers are there, how many even 4-digit numbers, 1, 2, 3 and 4. So even 4-digit numbers, so even means either 2 or 4 can be filled in the last position, so that it can be filled in 2p1 different ways, which is 2. So one number can be allotted in the last position out of that 2. Since repetition is not allowed, we are having total 5 digits and 1 is already allotted here. Remaining 4 digits are there and 3 spaces are there to fill. So it can be arranged in 4p3 different ways. Therefore, number of arrangements is equal to, or number of even numbers, number of 3-digit or 4-digit even numbers is equal to 4p3 into 2p1, and 4p3 means it is 4 factorial. 4 factorial divided by 4 minus 3 is 1 factorial into 2p1 means it is 2. So 4 factorial is 4 into 3 into 2, 24 into 2, that is 48. 48 4-digit even numbers can be made. Now next one, from a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So we have to select 2 persons from 8 persons. We have to arrange, that is 2 places are there only, 2 positions are there actually. 2 positions are there to fill and 8 persons are there. How many different arrangements are possible? That means which are the ways, in how many ways can we choose a chairman and vice chairman means how many different ways of selection, how many ways of arrangements it is possible. So 8 objects are there and 2 places are there to fill. So required arrangement, and repetition is not allowed because one person can hold only one position at a time. So required arrangements required number of arrangements is equal to 8 objects taken 2 at a time. That is equal to 8 factorial divided by 8 minus 2 is 6 factorial, and that is equal to 8 into 7, which is equal to 56 different ways. Then now next one, find n if n minus 1 p3 is to n p4 is equal to 1:9. What is n minus 1 p3? N minus 1 p3 is n minus 1 factorial divided by n minus 1 minus 3 factorial. Then is to means divided by n p4 is n factorial by n minus 4 factorial. That is equal to 1/9, and that is n minus 1 factorial divided by n minus 4 factorial into n minus 4 factorial divided by n factorial is equal to 1/9. Here we can see that n minus 4 factorial common, that can be cancelled. Remaining n minus 1 factorial divided by n factorial is the same as n into n minus 1 factorial is equal to 1/9. This n minus 1 factorial can be cancelled, and remaining we are getting 1 by n is equal to 1/9 or n is equal to 9. So the value of n is 9. So the remaining questions we will be discussing in the next video. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.